Hi dear students, my name is Sheikh Hussain and I am teaching chemistry for the last 22 years for IIT JEE and NEET. In this video, we are going to discuss the simple tricks to find number of valence electrons and valency. This is a very simple yet a very important concept, and it has many applications not only in general chemistry but also inorganic and organic chemistry. So without wasting time, let's start our topic, the finding valence electrons and valency. So let's write element. You also have taken notes for this element, name of the element, number of valence electrons and valency. I think you know what are valence electrons and what is valency. So before going to discuss this, let's have a brief discussion about valence electrons and valency. Suppose if you write electronic configuration of any element, say for example carbon atomic number 6, electronic configuration 1s2, 2s2, 2p2. So here what does it mean? Carbon has 6 electrons. Let's take carbon atom. For example, this is a carbon atom and it has a nucleus and it has 6 electrons total. Out of 6 electrons, 2 electrons are present in first orbit and 4 electrons are present in second orbit, 2s2, 2p2. 1s2 means in first orbit there are 2 electrons in s subshell, and 2s2 means there are 2 electrons in s subshell of second orbit, and 2p2 means 2 electrons in p subshell of second orbit. Totally in second orbit we can find 4 electrons in second orbit and 2 electrons in first orbit. So among 2 and 4, what are the outermost electrons? These are the outermost electrons. So for example, some students are there in the class. So in first bench 4 students, second bench 4 students, and in the third bench, which is the last bench of the class, for example, only 2 electrons or 2 students. So then how many students are there in the last bench? Only 2. So those students are called outermost students or outer valence students. Similarly, in an atom, the number of electrons present in the last shell, last orbit are called outermost electrons or valence electrons. Right? Now carbon is having how many valence electrons? 4. Carbon atomic number 6 and its valence electrons 4. Just remember this point, later we will discuss about this. Atomic number 6, valence electrons 4. What is the difference between atomic number and valence electrons? 2. 6 minus 4, that is 2. That 2 is nothing but, so these 2 electrons we are not considering because these electrons present in the first orbit. Okay, again we will discuss about this in briefly just after a few minutes. And what is a valency? Valency is a combining capacity of an atom. So in periodic table there are 18 group elements, first group to 18 groups. Out of all these groups elements, so the 18 group elements are noble gas elements which do not participate in chemical reactions. Except noble gas elements, remaining elements, that is first group, second group, third group and so on, all these elements participate in chemical reactions. Right? So participating in chemical reactions means they combine with other elements based on their available number of valence electrons. The combining capacity of an atom with another atom, combining capacity of an atom with another atom, one element with another element is called its valency. Right? Valency is a combining capacity, valence electrons is the outermost electrons. So here let's see very simply. So first hydrogen atomic number 1 and its number of valence electron also 1 and its valency also 1. We can easily remember for hydrogen everything is 1. Atomic number 1, valence electrons 1 and valency 1. And the second element helium is atomic number 2 and valence electrons also 2 but valency 0. Why valency 0 for helium? We know that noble gases helium, neon, argon, krypton, xenon, radon, these are called noble gases. All these noble gases belong to 18 group. They have 0 valency, means they do not participate in chemical reactions, but there are some limitations that we will discuss in some other class. So generally noble gases have 0 valency, they have zero combining capacity, right? Next, let's come to the other elements. So for example, atomic number 3, lithium atomic number 3. So here I will tell you one small trick. If the atomic number of the element starting from 3 to 10, that is from lithium to neon, if you want to find number of valence electrons of these elements from lithium to neon, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, so it's very simple. You just subtract 2 from its atomic number. That means 2 less than its atomic number. Say for example, lithium atomic number 3 and its valence electrons 1, 3 minus 2, 1, and valency also 1. If valence electrons 1, valency also 1. Now similarly, beryllium atomic number 4, so valence electrons 4 minus 2, 2, 2 less than 4, and valency also 2, its combining capacity is 2. And boron atomic number 5, and 2 less than 5 is 3, and valency also 3, boron combining capacity also 3. And next, carbon atomic number 6, number of valence electrons 4, 6 minus 2, 4, and its valency also 4. And next, nitrogen atomic number 7 and number of valence electrons 5, and its valency is not 5. If number of valence electrons are more than 4, if number of valence electrons more than 4, and to get valency we have a small formula. Valency is equal to number of valence electrons, 8 minus number of valence electrons, 8 minus number of valence electrons. See for example here, valence electrons 5, so it is more than 4, so valency of this element is 8 minus number of valence electrons 5, that is equal to 3. So valency of nitrogen is 3. So here, if the atomic number, here don't confuse, number of valence electrons will be less than 2 to its atomic number, but number of its valency will be 8 minus the number of valence electrons if the atomic number, if number of valence electrons are more than 4. Next, oxygen atomic number 8. If atomic number 8, then number of valence electrons will be 6. If number of valence electrons are more than 4, then what we need to do? We have to subtract from 8 to get its valency. So 8 minus 6 is equal to 2. So valency of oxygen is 2. And similarly, fluorine atomic number 9. So number of valence electrons 7. Since the number of valence electrons are more than 4, and we have to see the difference between 7 and 8, the difference between 7 and 8 is 1. So valency of fluorine is 1. And finally, neon, we already discussed that neon is a noble gas element. Noble gas elements have 0 valency. Let's see here, neon number of valence electrons will be 10 minus 2, that is equal to 8. If number of valence electrons are more than 4, we have to see the difference between 8 and 8, that is 8 minus 8, that is equal to 0. So in case of neon, valency is 0. That means neon is not going to combine with any other element. Its valency is 0. Its combining capacity is 0. So in this way, you can easily find number of valence electrons and valency of the elements whose atomic numbers will be less than 10. From 3 to 10, we can easily do like this, right? I hope you got this point, and if you have any doubt, and pause the video or go back to the previous explanation, note down everything, and you practice for 2-3 minutes and you will be perfect with this. Next, we'll discuss what about if the atomic number of the element is more than 10. It's so easy, it's easier than this one. See how we'll discuss. If atomic number is more than 10, for example, sodium atomic number 11, magnesium atomic number 12, aluminium atomic number 13, silicon atomic number 14, and phosphorus 15, sulfur 16, chlorine 17, argon 18, right? We'll see for these 8 elements first. So here very simple, there you see these atomic numbers here 11. So what is the digit in units place? 1. The digit in units place is 1. Here the digit in units place is 2, 3, 4, right? These are the valence electrons. Very simple. See here, so in sodium, what are the number of valence electrons? 1. In magnesium, 2. Atomic number 12, so 2. Atomic number 13, valence electrons 3. Atomic number 14, valence electrons 4. Atomic number 15, valence electrons 5. Atomic number 16, 6. 17, 7. 18, 8. So we can easily get the number of valence electrons just by knowing their atomic numbers. So if you know the number of valence electrons, calculating valence is very easy, as we discussed just in the before concept. So here, if the number of valence electrons are less than 4, then valence electrons and valency will be same. Suppose if valence electrons are 1, valency will be 1, valence electrons 2, valency 2, valence electrons 3, valency 3, valence electrons 4, valency also 4. If number of valence electrons are more than 4, then what we need to do? There is a formula to find the valency. Valency is equal to 8 minus number of valence electrons. If the number of valence electrons are more than 4. So here, what is the difference between 5 and 8? It is 3. So valence 3. So difference between 6 and 8, 2. Difference between 7 and 8, 1. Difference between 8 and 8, 0. So these are the valencies of these elements up to argon. Here again, argon is a noble gas element. We already know that noble gas elements have 0 valency. Now what about atomic number 19 and 20? Atomic number 19 is potassium. Potassium, atomic number 19. Here you may get one doubt, sir, atomic number 19, so number of valence electrons 9. No, the maximum number of valence electrons will be 8. If number of valence electrons 8 over, then again we'll start from 1. So 19, it belongs to alkali metal. Just like here you see sodium. Sodium number of valence electrons 1. Sodium, potassium, and in the previous discussion lithium, all belong to alkali metals, that is first group. They have number of valence electrons 1. So potassium have number of valence electrons 1. If valence electrons 1, valency also 1. And similarly calcium, atomic number 20. If 19 is having number of valence electrons 1, if it is an alkali metal, and next one calcium is alkaline earth metal, so its number of valence electrons will be 2 and its valency also 2. Otherwise you can do one more thing. Here after atomic number 18, you can take you can consider the 10th digit. Atomic number 19, you come to consider the 10th digit. What is the digit in 10th place? That is 1. Here the digit in 10th place is 2. So 1 and 2, you can easily get the answers. This is how you can easily find number of valence electrons and valencies. For the first two elements, hydrogen and helium, hydrogen valence atomic number 1, valence electrons 1 and valency 1. Helium atomic number 2, valence electrons 2, but valency is 0 because it's a noble gas. After helium, from atomic number 3 to 10, that is from lithium to neon, to find number of valence electrons, what we need to do? Just it's atomic number minus 2. You will get the number of valence electrons. From the number of valence electrons, you can find valency of any element. If the number of valence electrons are up to 4, its valency also will be equal to that number. If the number of valence electrons are more than 4, then we have to see the difference between the number of valence electrons and 8. That is 8 minus number of valence electrons. You will get the valency of that particular element. If the atomic number is from 11 to 18, then it's very easy to find the valence electrons and valency, because you need to just consider the digits in a units place gives the number of valence electrons. From that you can find valency. If in the case of sodium, potassium and calcium, you consider the digits in tens place, that gives you the number of valence electrons, and you can find valency. So I hope this video is very much helpful for you, and this video is a very simple video to find valence electrons and valency, but I challenge you, and you can easily find, if you practice this, you can easily find number of valence electrons and valency, which is very much helpful in calculating many bonding and Lewis dot structures, and valence electrons, valency of different elements, oxidation numbers, okay, and even in a hybridization, calculating the hybridization of different central atoms of different molecules, and all those many concepts. This simple basic topic is very much helpful for you. Okay, thank you for watching. If you feel this video is helpful for you, share with your friends and give one thumbs up, that is like, and subscribe to my channel.